Today we have Glauber on the top shelf, who is CEO of Terso, which is a cloud-based SQLite, and then also a longtime core contributor to Linux. Welcome, Glauber.
Thanks, Brian. That's one of the things I've done. I've done a lot of things in my career.
Yes, you've worked on ScyllaDB. You've been around DBs once or twice in your lifetime, and very difficult time problems, as you once told me, over some
very good drinks.
Brazilian mojitos.
Yeah, that's right. Yes.
Yeah, he brought you to Brazil, so all the Brazilians out there, this is the guy to thank.
Really, it was actually Glauber's full idea, and their team fully executed it. It was only Glauber.
And I told the team, look, just the Primogen just tweeted the word Brazil and got like 160,000 billion impressions on Twitter. Now, we're a remote company at Terso, we're all remote, and then we have to meet somewhere once a year. And I told the team, you know what we should do? We should just go to Brazil and bring Prime with us. And then we had help. We had ASEAN, we had other partners that help us to make that happen. But it was a great. This year we're going to Turkey, by the way, if you want to come.
Turkey. Oof.
We have a Russian national in the team, and he is very limited about places he can go. So,
well, one of the interesting things with your background and some of the stuff that you know, and some of the things Prime has lately been reacting to, is all of this Rust for Linux stuff. Prime, maybe you want to give a quick background on sort of the developments here and the current state of things for people who don't know, and then I'm pretty interested to get Glauber's take on what's going on there.
All right, so generally, Linus has said that he's optimistic or curious to see where Rust inside the Linux kernel is going to go. So over the last couple years, there's been a lot of effort put into bringing Rust in more and more into the development cycles, into the builds, into the staging. And so as of recently, some notable contributors have resigned, and a lot of it comes down to kind of the conflict of working with the C developers. And I believe if I were to give it the most charitable take, the difficulty that I see among all the mailing list threads is that there is not like a clear and definitive answer as to what is the expectation of development with Rust. Should Rust belong inside these core modules, or should it purely be a proxy on the outside and you have to constantly maintain the churn from within? Or should you not be able to even produce a patch without all the Rust builds successfully building, or can the Rust builds break even on the builds? And so there's been no clear direction there, I believe, if I'm giving the most charitable read here. And so it appears there's a lot of confusion, which is leading to a lot of fighting, which is leading to people quitting. And there's plenty of other problems, but that would probably be the nicest way. And so you've obviously been on the contributing side and probably the reviewing side, and probably have sent hundreds of Linux kernel mailing list messages.
Thousands, yeah.
Thousands. What is kind of your take on the situation?
Yeah. So, and just to clarify, I don't contribute to Linux anymore in a while. I actually kept, even after I was at Scylla, occasionally I would find a bug in some driver or something, then I would fix it. But especially now, as the founder of a company, I have very little time for everything that's not core to what I'm doing. So I don't contribute to Linux directly for a while. But when I look at discussions, and the other day I saw the video of you reacting to a presentation that somebody gave about Rust for Linux, very little, I think, changed, right? So I think the first thing that people have to understand about the Linux community.
Sorry, can I interrupt 1 second just to give the proper context? It was about 6 months ago that I did this, and it was a presentation where someone was talking about Rust, and they got to slide 2 of a 50-slide presentation, and the entire hour was just spent arguing over slide 1, 2, and 3. So they got nowhere. And apparently this is very normal, regular.
Your comment on the stream was look, they can't even let the guy finish. And then what I texted you immediately is look, this is so pervasive in Linux that the first time that I went to a conference that wasn't a Linux conference, I was actually flabbergasted that people would just go through their slides. It felt weird. I mean, because you have to understand, I started my career in the Linux kernel. That was the first job I've ever had. That was the first open source project that I ever participated in. And every single presentation, every single conference, was just people fighting all the time. I tell the story that the first contribution that I had to the Linux kernel was some fix for the ext2 ext3 file system at the time. ext4 was super new, so ext3 file system might even have been ext2. That was in 2004. Like, so that was the first time I officially contributed to the Linux kernel, and we all saw those guys in Linux as like demigods, right? And I knew their names. I would follow the mailing list, and we would read stuff about them. And I remember that I sent this thing. I mean, it was a very emotional moment to me. It was like I sent code to the Linux kernel, and then I see the email popping up as a response, all viral. It was one of those guys that I've only heard about, and I had this dream like one day I want to meet this guy, and then he responds that I've never seen code this bad in my life. You managed to introduce 3 new bugs and 2 new lines of code, and people like you should never be allowed to get close to a keyboard again. So that was my introduction to Linux, and I started, after a while, I think I got a little bit better. I started introducing like 1 bug in 3 lines of code, and then maybe 0.
You're like get better at like GitHub Copilot speeds right now,
Exactly, So at some point, and then I started working at Red Hat. I started doing like relevant stuff, and then we would go to the conferences, and the conferences are all like that. Like somebody says something, and then there's a flame war about that something, and it goes like so. To your point, the Linux community is a very organic community. So like people don't not say things. If something crosses your mind, and the discussions in the mailing list, if you follow the discussions, like they go into tangents all the time. And then somebody says this one thing and people start discussing like that one thing, and it goes in wild directions. So what you're saying about Rust for Linux doesn't surprise me, right? This thing about, there's no clear direction. Yes, I will be very surprised if there was any clear direction in anything. And look, it kind of works. It kind of works because like Linux is undoubtedly a success, right? Just there is no other open source project that is as successful at Linux. Depending on the metrics, that's a clear. There's clearly no open source project that is as successful as Linux. So that wild mess kind of works. So look, I wouldn't expect clear directions from anybody. It's more like things are organically evolving that way, and Linux spoiled me in a lot of ways because of this. Because when I started working at Scylla, for example, I had this idea, and I swear I didn't do it on purpose, but I kind of had this idea that. Yeah, I mean, you don't have to test your code that well. I mean, you test it, but you don't have to test your code that well, because what happens is that you send your code, and it gets, even if it gets merged, 3 days later you're gonna have 40,000 people commenting on it, right? And I associated that with like how open source works, but it's not how open source works. It's how Linux works, because everything you do has like 10,000 people looking at it and scrutinizing from every single angle. So you kind of get lazy in a way. So I mean, I got spoiled by that. But you just have to think of Linux as this massive community with like literally tens of thousands of people doing stuff all the time. And it's very hard for anybody to have like clear directions on the plan. I mean, I don't think there is a plan, right, at the end of the day.
But I mean, I love that idea that you can commit stuff and people will just tell you immediately when you're wrong. It's the greatest CI of all time, because not only is it wrong, they're probably super motivated. They open up the code, look at the patch,
and they
they're like,
you.
You look at this line right here. Who wrote this garbage? You wrote this garbage. What was wrong, actually, is that you went to do cast it, and you're just like, oh, yeah, of course. Thank you for that.
Thank you.
I will now fix
Andrew Martin, Andrew Martin. I've seen other people saying similar things. I mean, I'm not even claiming he invented that. I'm just claiming I heard first from him. Andrew Morton at the time was like when I was at the peak of my contributions, he was the second in command for Linux. Again, I don't know if that's still the case. And one day he told me, like, look, if you're not getting responses to your code, just send something wrong, right? Because sometimes people set like questions, should I go this direction? I mean, I have this, maybe we should pursue things this way or that way. And then like sometimes people comment, sometimes people don't. And what he said is like, just code something wrong and send it to them, because that people will comment, right? And it's just the kind of personality I think that gets attracted to Linux, and guilty as charged. People who really like to nerd snipe on things and go really really deep into this one thing, and it has this consequence. Like yes, you kind of unearth the craziest bugs, because people working on Linux, and that was always been the case, are really 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 good. Which again, it's something that I didn't appreciate until much later in my career. Like how you're working like in a quote unquote normal team with normal people. You don't have that. Like if you're working on the Linux kernel, like whatever you do, and you get much better, by the way. So if you can stomach for the people who are in the beginning of their career, one advice I have, just go work on Linux, because you're going to be more, if you develop the thick skin of learning to live with that. It was great for me, and it's going to be great for you too. But as a consequence of that, I think things are a lot more organic than you're used to, right? Things are a lot higher level in skill level than you used to. Look, I worked for Datadog for a year, and Datadog is a public company, is a great company. They have amazing technology, but that was the first time in my life that I look around and I saw that I'm surrounded by normal people. Right, because the Scylla folks were also an offshoot of the same group that we worked with in the Linux kernel, and so just it's a very wild environment. It's a very high intensity environment, but also I think that the other side of that is that there is no direction. Forget about it, right? And a lot of people end up leaving. Yeah, a lot of people end up leaving. Like they say, I don't know those people, right? Specifics, right? But the case for me is that at some point I also got tired of all the fighting, right? After 10 years, it takes a toll on you, right? So it might have been, I venture to guess that there might have been a component of that as well, right?
I absolutely love that. My time, the early days of working at Netflix had a very similar vibe, in the sense that I'd make a change. No one would really comment on it. I'd merge it in, and then I'd be pulled aside by like the old guard and be thoroughly chewed out about, like, look at this inefficiency. We were programming JavaScript at that time, but it was embedded JavaScript that we hand kind of rolled into TVs. So like every last allocation mattered, and they were just so upset that an object was created per click, and we had to like have a long discussion about how this was happening. And I was just like, this is just such a different experience, just having this kind of free world to do whatever you want. But the moment like it actually got out there, then people just like clobbered it and brought it down. It was it was actually a really great environment, and I probably learned the most because of that freedom to hang yourself, but also the freedom to or also the responsibility of your coworkers to kind of like up level you, even if it is in a little bit of a harsh way. But I do want to go on.
I was just going to comment that the equivalent of that for us was essentially like, what kind of code would the compiler generate? It was something like you would do something, and then somebody, and I have a very specific person in mind, because he was the king of that, Peter Zustra, the guy he was one of the maintainers at the time of the scheduler. And again, the scheduler really is a place where all of that matters. You're like fighting about cache line orientation and alignment, and he would come at you and say, don't write the code this way, because the GCC is not great at generating code with this pattern. You should write the code this other way, because then then you go look at it, it's kind of true. So I learned a lot about how compilers work just working on Linux, because you really have to understand, for you write code this way, the compiler tends to generate code this other way, right?
That sounds like just a constant losing battle, by the way, having to try to guess or try to stay ahead of compiler changes on such a large project, to be like, well, new optimization just dropped, boys. Let's get back to that compiler and start rewriting stuff.
Yeah, there's a trick for that, which is autism. I mean, I'm not diagnosing anybody here, but like I think in our industry in general, there's a high prevalence of that, and I'm guilty as charged as well. But it definitely helps to stay ahead of the curve. So
quick, I want you to kind of maybe talk a little bit more about Rust, because you obviously with Terso have leaned in heavily on Rust. You're rewriting SQLite with Rust and this whole Rust for Linux thing. How do you think there's a successful future for Rust in the Linux kernel? And is this just a matter of attrition and waiting for old hands to leave the Linux kernel, and the currently young, which will soon be old hands in the Linux kernel, maintaining a 20-year wait to get Rust in? Is that the strategy, or like what's the play here?
I am optimistic, and first of all, I like Rust a lot, and I think the Rust folks that contributing to Linux are doing it in the right way, because there's also, I just described this environment where like everybody's a super genius, but there's a lot of garbage code in the Linux kernel as well. And that code tends to be in drivers, because what happens with drivers is exactly like, look, you as the maintainer don't quite understand how that works, because it's like this graphic card that I don't even have the specs for, and just part of that is just writing code. So writing code is it's always the same. Like also like nobody truly cares. I wrote code for the core of the Linux kernel most of my career, was things like the scheduler, file systems, memory management, resource allocation. So you write bugs and this kind of things. Yes, like 10,000 people will notice. Like somebody runs your code and notices, like I remember happened many times, the day after, my workload got 20% slower, and then they get bisect to your patch and they send you an angry email and say, just the Glover, you just made my computer 20% slower, and then you go figure out a real story, and then you go figure out why. But in drivers, none of that happens, because first of all, nobody's running that stuff. Just a person, and Linux has always had this policy, like we want to support every piece of hardware out there. So there are many pieces of hardware that like 4 people in the world have access to, and it's not something that people care about that deeply. So you end up having a lot of substandard code in drivers, and this is exactly from my understanding what the Rust for Linux folks are trying to do. Like, let's write drivers with this. Like nobody's pushing necessarily let's rewrite the scheduler. With Rust is like, if we have a memory safe language, can we make the situation at the margins of the Linux kernel a little bit better, which I think is a great strategy. And look, I don't think you need the old guard to die out. This what's happening sounds very ominous in the sense of people are leaving and like but this happened in the Linux kernel all the time. I can remember 5 examples, easily on my head, where people called an idea, and again, people are very harsh, so called an idea like complete bullshit, the worst thing I've seen in my life. Even Linux gets involved and say only stupid people will do this, and then 5 years later, everybody's on board, because people are also very rational. So I think if Rust proves itself, it will face a lot of opposition, which again I think it's harsh, it's hard to deal with, it takes a toll on you. But when you look at the health of the project, it's actually not bad, because if you manage to win the battle, you have something really solid at the other end, right? So, and again, the one example is the first thing I work with, virtualization. Linus Torvalds himself was completely against it. He said things, at the time, like, over my dead body, Linux will ever support virtualization because that's a stupid idea. I don't see the value on it, and et cetera, and et cetera, and et cetera, time and time again. It's there. Every Linux kernel today is also moonlights as a hypervisor. Another example, IOU ring, something that I didn't work in the kernel too much. I fixed a couple of bugs, but I used it as a user at Scylla, and now Limbo, our new project at Turso, also supports that. I used it at Datadog, and it's essentially Linus Torvalds himself was very against the idea of asynchronous system calls as a generic construct, and then IOU ring came and did it in a way that was acceptable. And now it's there. So there are many examples of things that the community was viscerally and brutally against, and then you fast forward 5 years and everybody's on board. So my hope is that the same will happen for Rust for Linux. It will prove it. Organic. It may not happen, but I think what you will see is that you're going to see this organic development. People end up finding solutions for the problem. Some people die along the way. I remember, that was in 2005 when the Linux 2.6 was coming out. There was this one scheduler implementation from this guy called Con Calivas. He was a virtuoso. He wrote like tons and tons and tons of code for the Linux kernel, and he was trying to prove that the specific type of scheduler that he was writing was superior to what Linux had. Eventually, he got tired. he quit. But his ideas lived on, and 3 years later, Ingo adopted exactly the scheduler that this guy was pushing. So it happened time and time again. It's not anything new. I think that's what's going to happen with Rust. I think Rust has a bright future, and if it truly has, in 3 years, in 5 years, we're going to be having a very different discussion. People are going to be on board. There's always the one person, the two people that people are still shit talking System D years later, as it was like the worst development, and that's fine. Life goes on. So you have to abstract away the violence a little bit, and then everything makes sense.
Yeah, it is. I mean, it is super common in just like any open source project to have a bunch of this stuff here. I remember when I was working on bringing LSP into NeoVim, like people were pretty excited about it. Like I worked on it for a while, and then I like switched jobs and I didn't have time to work on it, so I stopped, and then like someone else picked it up, and then they had to stop and someone else picked it up, and then they finally merged it. And then I also happened to come back. By then I was at a different job again, and I had a bunch of time to work on it, and then it's like now it's there, it's used a bunch, everybody uses it, right? So it's like it's a pretty common thing just in open source that people, for various reasons, like decide that they're not going to go, and it's not always like some mysterious flame war with political subtext or something like that. Yeah. Sometimes it's just like, well, I'm kind of tired.
It does happen, but the tire in that case, I mean, this guy in particular was very passionate, and he just got tired of the violence in a sense, because I mean, Linux is a very violent community. It truly is. And what happened, verbally violent, right? I want to clarify that I've never seen anybody, just. Might have happened. I'm not saying that it never happened.
Maybe at one of the conferences, they were like, I really wanted to get to slide 4, guys. I'm about to beat you guys up if I don't get to slide 4 here.
If it happened, it didn't happen to me or in any situation that I was a part of. But, just the verbal violence is definitely there.
Yeah.
And at some point you get tired, and I think it was one of the factors. It was not the thing, but it was one of the things that led me to look around and say, maybe I want to do something else now after 10 years of this. I mean, it gets tiring. But here's the thing: I'm running a startup today, right? And a lot in the startup world, people have those terms of like product market fit and this and that, and like how do you know? Like, doing things is not hard. Figuring out what to do is the hard part. Like, doing things is easy compared to figuring out what to do and what has value, what doesn't have value. And in a sense, what you just described proves that what you were doing had value, because you stopped doing it and somebody else picked up, right? So I think the Linux kernel ends up being like this filter, because look, there are people doing stuff all the time, and there are people fighting all the time, and there are people dropping all the time. The things that survive are the things that have value at the end of the day, because he had to survive this process of like people bickering and fighting, and if it's just a fad, like sometimes it took me. There was one particular piece of work that I was doing that it took me a year and a half to get in. That's when I met Pekka, by the way, and it's mostly his fault, and it's why sometimes I have this love-hate relationship with him, because but Pekka being my co-founder at Turso, but it was something that I had the patches ready to go. I worked on it for 2 months, and then I had an idea of that works, and it took me a year and a half to get this merged into the Linux kernel, right? If it's something that doesn't have value beyond like 3 months, this work dies, right? So it's a sifting process to find out like what truly has value, what truly works, what truly should be here. Or not. So it's a beautiful process at the end of the day. It can be taxing, but it's a beautiful process, I think.
Do you think it's the ideal process, in the sense that when you read through the stuff, it is a bit harsh of feedback, or at least perhaps it's harsh based on my just view of the world at this point, just because I've been kind of, I guess, I'm not sure the proper word, I'll just call playgroundized for my code feedback, right? Which is, you should never say anything negative. It should always be like, all those things that kind of go in. Is it an ideal form? Do you think there's things that could improve? And do people quit because of how negative it is, or is it just simply because of how slow it is?
No, I've never seen anybody quitting because of how slow the process is. And In fact, as I said, I got very spoiled because for me, like software development was in Linux. There is no sense of urgency for anything, because it's always like, look, we're going to find the best solution, right? Just there's no argument. Like nobody ever makes arguments. And again, I worked at Red Hat for 7-8 years out of the 10 years that I was in the kernel, and in the company, you have this idea of like, hey, look, we have this customer issue, we need to do something about it, and etc. But Red Hat was a company that understood this very well, which is why they were so successful. This kinds of arguments just don't fly in the Linux kernel because the way it didn't start as a company. It evolved as like this group of people doing things, right? And you show up there and you say like, we're going to do this because I have 10,000 customers in my company that need this. Like the answer, like it's going to start with it's the F word. It's really like I don't care. Like why are you even saying this? Like so there's no sense of urgency for anything. Like people send code. And the response you're going to get is like, is this the best? Is this not the best? Is this the best direction? And sometimes, one time I wanted to do something fairly small in the x86-64 architecture. So it was something, the boot sequence. And I sent it took me a week and a half to write the code. I sent this to the maintainer at the time. His response was, when I think about it, I actually don't see a reason anymore for the x86, the 32-bit version of the code, and x86-64 to be two different implementations. They should be the same implementation. So this, yes, you want this thing that took you 1 week to do, merge into the Linux kernel. Before I accept that, I want you to completely rewrite the boot sequence for both processors to be the same. Mm-hmm. And like, there's no sense. And if you don't want to do it, then you don't want to do it. Like, that's fine. Then, but I'm not going to merge this code because I think it's moving us in the wrong direction. The right direction is that those two trees should be the same. Mm-hmm. And then I spent a year and a half merging the two trees together. For me, by the way, it was fantastic because I learned so much about all sorts of things. And okay, now that I did a year and a half of work, I can go back to that week project that I have and merge it in. So there's no sense of urgency, but in a sense, I mean, it's actually pretty awesome because you don't have those pressures. Like there's no pressure for compromise. But what I saw many people leaving for is the harshness. That is something that I think pushes a lot of people away. And is it the ideal process? I think if we could have the process of Linux without the harshness, then I think it will be much better. So obviously, I think it will be much better. I don't know if you can though. I mean, being quite honest, because it's one of those things. Like if people dance too much around things, what ends up happening is that you bury the truth, right? Mm-hmm. Because you think something, but you can't really say it because it's not the way. And I think this harshness that you see in Linux is just a result of people being very direct all the time. This is what now. You could do this without calling people morons, and some people do. I mean, there are some people in the Linux kernel, by the way. There are some people that are fantastic. I mean, Andrew Morton is one of them. Like, I never screamed at anybody. Pekka never screamed at anybody. Pekka can be a little bit rough sometimes, but never at this like this. Mm-hmm. Jens Axbo, the guy from IOU Ring, is a fantastic guy. Greg Kroll Hartman was always a very welcoming person. So you have those kinds of people within the Linux community. So it's possible to do. But Linux attracts a kind of people that usually doesn't have this level of self-awareness, and so in practice, I don't know if I would love to see it. I think if Linux can evolve to a point where we can resolve those disputes by telling the truth without telling people that you would prefer that they never get close to a keyboard again, I think it will be a net win for the community, and I hope they get there. But it's easier said than done. I think that's my point.
Yeah, I think there's two difficult sides of it too. There's the other side is, I think a lot of people, when they receive direct feedback, it's just as harsh if it says one mildly critical thing as it would be harsh for them to receive as like, F you, you're so dumb, you should never touch a keyboard. Like those are equivalent, like the way that they feel about getting that feedback is the same, which also like makes it very difficult to have the conversation, because sometimes you're like, all I said was I think we should do it different. Like why is that person so upset, right? So there is also, you know, sort of this flip side too of people need to come, you know, prepared to have any kind of feedback. And I don't necessarily see people always like being really well prepared for that either. So even in the ideal world, everyone somehow figures out how to give direct feedback without calling names. A lot of people still aren't ready to receive the direct feedback anyways.
And it's something like, remember, like, you know, I remember you weren't there, neither was I, but you have those things today, like sometimes somebody posts a exam from 5th grade in 1965 and like this super complex stuff that just today is like college level math. So there's something to be said about the bar as well, right? So yeah, I mean, you don't call people names, which, by the way, a lot of people just get used to. It's just not my personality, because I'm a friendly person. And then you move to just direct feedback, even if you could enforce it, because, you know, that's the hard part. Even if you could enforce it, yeah, the bar is now a little bit lower, and now people start taking offense to the direct feedback, right? It's just right. So that's what I think. In practice, it's hard. Yeah. I don't think it's the ideal development, but I think it's the development that's been working for Linux in a sense, right?
Speaking of open source projects, you know, with trying to grab a lot of different contributors and working sort of all over the world on a really difficult thing, I'm interested in some of the experience you've been having with your, I guess it really can be called a SQLite rewrite, right? That would probably be the proper term in Limbo. But maybe before we jump directly to there, you could talk just real quick for some people who don't know how you got to the place where it makes sense to do a SQLite rewrite, because it sounds pretty insane off the rip.
Well, you know, it's insane is not necessarily a bad word, so I'll take it. But you know, in the Linux, one of the things that we always wanted, maybe we can go to I can go to therapy here with you guys, right? Just, I'll lay here down, have my couch right there. You know,
we're listening.
It could be just you know. That guy and I always wanted to have this experience of the Linux kernel again, right? So, you know, maybe we're masochists; we like to suffer, but without the violence, right? So that's the you know the gold standard. Like, can we do this? And around 2 years ago, we know, okay, we love SQLite. SQLite is, you know, which officially I've been calling SQLite, mostly because of Brian.
You're welcome.
Yeah, which I think it's a great pronunciation, but we love it. I think it's a great database, a database that goes everywhere. And I don't come from this web background. Up until very recently, I never touched JavaScript in my life. Do not know how happy I was, and so SQLite has this appeal of like a database that runs in embedded devices. It runs in you know, it works everywhere. It runs on military fleets and whatnot. And I want to be careful with that, because sometimes I get flamed on X for two reasons. First, because I think people just like it. You know, it's fun. Talking about Linux, you know, it's something human about us. People just like fighting. People say they don't, but we do. So, but the reason I sometimes get flamed is that people understand that I'm attacking the SQLite development model, which I'm not. Okay, this is what I've tried to make it always very clear. So, what is the SQLite development model for those who don't know? Because a lot of people actually claim that they do not know this. SQLite is a project that is called open source, but not open contribution. So they don't accept your code. They just don't. It is maintained by 3 people. And that is the SQLite community of developers, so to speak, right? So the test, SQLite is known to be like probably the most stable piece of software in the world. They're maniacal about like getting everything tested, thoroughly tested, you know. But the test suite is proprietary. So you can't really, if you make changes to SQLite, you can't really test it. your changes. And I'm not saying that there is something like immoral about this, which is, what some people sometimes understand, or fundamentally wrong. But I do think that that's not how I would run a project. And I do think that the idea that some people have that this is the only reason why SQLite is great, because it's kept, the only way to make something great is if you only have 3 people doing this. And, if you take this away, that won't work anymore. I think this is fundamentally false. And the data point that I have for this is Linux. Again, because Linux started as this, very small. If you read the letter that Linus originally wrote, it's like, this is a toy project. This will never work outside of my computer. And look where it is today. It will get bloated, right? SQLite would get bloated if you had contributors. No, because again, Linux works in supercomputers, and it works on embedded devices, and it works everywhere. So, it is possible to do, and Pekka and I have the experience to do it. So we always wanted to create what could SQLite be? Because you give something away, like the creativity that comes with Linux, with this organic thing, the community coming up with this thing that you never imagined something would ever do. And then one day this person shows up and does it. I remember the first time I read about kexec. Kexec is something that was essentially a way that this guy, Eric, found out to reboot your kernel into another kernel. Right, so it is insane what he has done, and then people started using this to essentially, if it crashes, if the Linux kernel crashes, it boots into the kexec kernel, and then I can extract a core dump from a kernel, right? So nobody ever thought this was possible to do. This one day, this dude shows up and does it, right? So this wasn't on anybody's plan. This wasn't on anybody's roadmap. So. Yes, maybe you don't have the violence. There are advantages, maybe, granted, of keeping things small, but you lose in this creativity. You lose in this idea of people coming and contributing and doing crazy stuff. So we wanted to recreate this with SQLite. We say, hey, we love SQLite, but what if we could have a open contribution version of SQLite? That was the dream for us. That was what we wanted to do. Where could we take this thing? And 2 years ago, we looked at this problem, and there's a lot of that is a lot of people are talking about SQLite. I think people are rediscovering SQLite. SQLite is a database that we always loved, that we always used in many ways. So we had this idea: what if we fork SQLite instead? What if we fork SQLite, right? And just run with that. The argument against the fork is usually when you fork, you fragment the community. But in our mind, is there is no community, so there's nothing to fragment, and we're gonna fork it because then we don't have to worry about maintaining compatibility, and we can start from a base, and we can go from there, and that's what we did. So 2 years ago, we forked SQLite because of that. But in the back of our mind, what we wanted to do, mostly because it's fun, was to rewrite it, right? And we thought we were being the adults in the room. It's so fun to rewrite it, but I guess the lesson here is unleash your inner child sometimes, because the results are better sometimes.
Prime's pretty good at that, yeah.
Yeah, and when it works, man. And we wanted to rewrite. We figure, look, a rewrite in Rust or Zig. We look at both languages. Will be fantastic. It will be super fun to do. I think it can take us very far. But we kind of decided to fork it instead because of this. You don't lose too much by forking. There's no community. But over time, it started to feel that maybe it wasn't the right decision, technically. And I think a large part of that is the fact that it's very hard to test your changes because the test suite for SQLite is proprietary. And also, again, I'm going to say this in the most charitable way possible. SQLite is a great end result piece of software, but when you're writing software for yourself that nobody else will ever contribute, you write things in a specific way. And when you write code for Linux, where you expect people to come and contribute, you write software in a completely different way, because readability, maintainability, and things like that are a part of your decision-making process. And when you're writing code just for yourself, it's a different thing. And SQLite is like that, right? So making changes to SQLite, to the SQLite architecture, like there's no modularity, like things cross boundaries all the time. It's very hard to understand the changes that you're making and how they impact and then the test suite is proprietary. We added a lot of features to our fork called libsql, but it was very, very hard to make foundational changes. And then we started playing with the idea of a rewrite, right? So what happened is that in December 2024, it got to the point that it can read data from SQLite just fine. Most queries work. You can't write data. Now you can, but without transactions. But the project, it started just really as a side project that we were playing with. Like we didn't have any, like Turso as a company didn't have necessarily an idea to use it. It was a side project. If it works, sure. I mean, in a couple of years, we might use it instead of what we have today. But in December 2024, we announced that we had this idea, because it was something that was just Pekka and I talking about it, and a couple of other people who showed up. This was on his GitHub repository. It wasn't even on the Turso GitHub repository. Not organization, not repository. And look, the results were wild, man. The results were wild. We had 8,000 GitHub stars in less than a month. We have now 87 contributors to the project. Wow. 87 contributors to the project. So, and again, remember, for us, this is a template. Like, can we recreate this community of contributors? And this creativity of like people showing up and doing crazy things that we haven't thought about is already happening.
Yeah.
Right. There is this dude. I don't know how to pronounce his name. So I'm not going to even try not to butcher it. But he's coming and like doing like very interesting work in the simulator specifically. I'm going to talk more about the simulator. That it's not work that we thought about doing, and he's improving a lot the way we simulate. Right, and it's not something that wasn't on anybody's roadmap. We have this guy in prison, which I recently learned is not the same as jail. That came and started like doing tremendously good contributions. Other people, and so we're starting to form this community, which is what we truly wanted. And when we ask those people, why are you spending your time on this? What we hear time and time again is that, look, we all agree with your idea of libsql, the fork, the SQLite can be more, that we can do more. But, this is the stuff that excites me, like a full rewrite, the blank canvas, the opportunity to just do everything from scratch. That is what excites. So the way I've been describing is like with this analogy from chemistry, like activation energy. With libsql, the fork, the reaction almost happened, but it didn't quite got to the activation energy. And with the rewrite, like it really did. So I mean, we can't use it in our product today because it's not ready, right? But we made a lot of changes to the company to allow us to have the mind space and the resources to really, which is essentially like anything else that we had on the roadmap for this year, cut it, drop it, or modify it, and we need to put people. And yet, without us contributing to the project, again, we have 87 contributors. Week after week, we have more and more commits because the community is really coming. So what we think we can do is like get this project, which is like a database that can run everywhere, a database that can run on your headset, on your toaster, on airplanes. Hopefully not the airplane in Toronto that just flipped upside down, but everywhere, and get a community of people to run with the same level of quality that SQLite has. For us, this is the important part, right? If it doesn't have the same level of quality that SQLite has, then nobody's going to use it, because people use SQLite not because it's fancy, but because you can trust it. And the way we're doing this is through deterministic simulation testing, which I know, Prime, is something that you enjoy a lot, which is essentially...
I love the idea of it, which is it's actually extremely difficult to really execute well. That's why I'm so interested in what you're doing.
And again, we even if we're not doing well, this dude came and he is doing, and I know he's associated with a university, and Becca knows him a lot better. And might be, might be because he's interested from his thesis or whatnot. I don't know, but this is the kind of people you attract, and this is what we want to do. And the idea of deterministic simulation testing is essentially how to code with no bugs, right? In a way, it's not that there are no bugs, but you have a fuzzer attached to a simulator. And the simulator abstracts all the I/O, everything that in the system that could be non-deterministic, timing, interrupts, events, I/O, like data returning from storage. Sometimes it takes longer. Sometimes it takes, right? And in every system, you start having those very weird interactions, like, oh, this bug only happens when the disk is nearly full, and then fsync took a little bit longer, and like you have all of those bugs. And then in the simulator with a fuzzer, you can simulate all of those scenarios. So hundreds of years of execution in one day. And if it fails, so the bugs are there. So it's not that you don't have bugs, but when it fails, you can reproduce every single step exactly, leading you to that point. So you take the crazy reasoning about, like, because that's how we did it in Linux, by the way. Like, those things would happen. Like, there was a scheduler bug. You have to spend like a week reasoning about how, okay, so maybe what happened is that, like, this memory got accessed when this other thing happened. It takes a week just to come up with a theory. And with deterministic simulation testing, if a bug happens, you know exactly. Like, you can reproduce this exactly to every single step. So the bugs are there, but you find them quickly and you solve them very quickly. And we think this is what can be the replacement to the mythical SQLite test suite, right?
Interesting. So how do you know that you're like, I guess when it comes to this simulation testing, you're attempting to do everything, is truly the fuzzer the thing that you're relying on the most, or what makes it so that you have such a high degree of confidence with simulation testing? You're not just categorically missing huge chunks that you just don't even know about, right? Like the unknown unknowns of development.
Yeah. So it's mostly on the fuzzer, right? And on the fact that you hook into the I/O subsystem, because the things that you want to simulate. So first of all, the way you verify the system is through property testing. So it's not like you write a unit test and you expect this result. It's like those are the properties of the system that need to hold, right? So you know more or less, right? Just if something happens that doesn't keep those properties, there's a bug, right? So, and then you go investigate the bug. It's less direct than a unit test. When a unit test fails, you know exactly, okay, this thing here is exactly what failed. This should be 0, now it's 1. With property testing, it's less direct than that. It's like we encoded expected behavior of the system, and those behavior failed, and now I need to understand why exactly they failed. But I'll give you an example of something that we're chasing at the moment, which is a fairly easy one to understand. If the SQLite database, you can run an integrity check on the database and verify that the pointers of the database are all pointing to each other, right? The database is not corrupt. If any of those things, if the integrity check fails, it means that the file is corrupt. So what you can do is that you run the fuzzer, you do everything, and then you run the integrity check, and you see if the database is corrupt or not, right? So this is an example of property testing. When you see that the database is corrupt, you don't at that point understand why. I mean, it's less direct than a unit test. You have to now go and investigate, but you know there's something wrong. And why is the database corrupt? Because fsync failed, or the operating system returned a partial write, or because the data was supposed to be written here and you had a pointer error, and because the database was too big, and you had a off by one error at the end, right? So those are exactly the things that the simulator is doing, because it's hooked on the I/O subsystem, right? Is faulty things. And the combination of those many faulty things, because this is the hard part, right? You want to test one thing, sure. Things that we tested ad nauseum in the past, like how does the database behave if there's no space left on the device, right? You can test that, but what if this happens at the same time that this other thing happens? So the fuzzer is just trying to create all of those weird combinations of things, and then you run a property check, for example, an integrity check on the database, and see, is this corrupt or not? And if it is corrupt, now you know exactly every single step that happened deterministically, one after the other, that led to that. And in 2 days, you have the fix for the issue. Right?
So does that mean you don't necessarily codify like expected values? It's more that there's certain set of states. Now, it sounds like you're also kind of getting close to the NASA's Power of 10 programming, which is a set of 10 rules in which they're claiming produces highly reliable software. I think Tiger Beetle is really into it, their Tiger style, or at least some subset of all of that. Do you practice any of this highly reliable stuff? And if you do, is it actually that painful, or is it really enabling you to go faster?
Well, yeah. So we practice a lot of that. Not as much as Tiger Beetle, because Yoran is frankly insane. In the most loving way possible. And
he makes talented developers look completely hampered comparatively. Yeah.
So just I don't think we would go, and it's because it's not necessary. Like it's great, but it's not necessary, and it's not necessary at all stages of the development as well. Like but Yoran is frankly insane, and again, I love him, and I say this on the best way possible. But they're also, and I think it works for them in a beautiful way. But you practice a lot of that. So, for example, one of the things that we don't use in our reimplementation is any async runtime. So you're writing asynchronous code, because one of the things that we already do very differently from SQLite is the SQLite has a synchronous interface, which means like you call SQLite step, which is their main API, and then that returns synchronously. Now, we want to make it asynchronous because it's easier. And people get confused with that sometimes. It doesn't mean we use an async runtime. It means that the API that I'm offering you may return, I'm not ready. That's all that means, right? Because then if I'm not ready, that allows you to do things, for example, back this database on S3. Because the data is not local, right? And then you ask me for a page that I don't have it locally, I return not ready. And then the async runtime that you're using later calls into me. Like if you were to implement this S3 backend for SQLite has a synchronous interface, it would block until the pages are here. And we don't have an S3 backend for Limbo yet, but you could have an S3 backend. We have it working on the browser already. And you do cool things like that because you have an asynchronous interface. But we don't use a asynchronous Rust runtime. And one of the reasons we don't use a Rust asynchronous runtime is that those runtimes will introduce a lot of non-determinism. Like they may back something by threads. They may put memory allocations in places that you were not expecting, and so you one of the disadvantages is that you have to go through some level of pain and rewrite things, right, more than you expected, more than you would otherwise if you were just like a free to consume from the ecosystem, which you're not when you're doing deterministic simulation testing.
Does that mean you kind of sorry, TJ, go.
Does the lack of using a Rust runtime directly, does that help you guys embed in a bunch of different places too? Like you said, you wanted to be able to run anywhere, right? Like I think not all of the Rust, like I'm not sure Tokyo runs like in Wasm and stuff, or at least easily.
Exactly. Yeah. So one of the things, like with libsql, the fork, we did a lot of that. So we didn't go all the way into this level because it was a fork. Many different reasons as to why, but we had a lot of trouble running. So one of the things that people kept asking, because Turso, the company that I represent, we have a syncing thing that syncs SQLite databases to and from places. And so we can use this, for example, that you don't have a cache. So imagine you have your SQLite database and you write into this database. And then I put a copy of this database in your server. So you can keep reading from this database at microsecond level speed, right? That's awesome. But the community kept asking us, that's amazing, but do this on the browser because I want to put the database like in the browser. But with Tokyo and all the runtimes and stuff like that, it's pretty hard. So we've never done it. Now, the browser also has a lot of requirements for things to be asynchronous. Like you can't block on the browser because you block your whole tab. So it does help us running with the mission of running everywhere, right? But you also have to be very conscious about dependency. Like SQLite has a no dependency policy They do not have any dependencies, and part of that is because they want the code to be public domain. Like our code is MIT. We believe a proper open source license is important for what we're doing to create a sense of community. We do not have we don't have any no dependencies policy. In fact, we are a lot more lax in because SQLite comes as well with a shell. We also have our shell, and in the shell you're a lot more relaxed. I mean, the shell doesn't have to have those requirements, right? So you can relax this a little bit, but we are very careful with the dependencies that we bring in, because we need to make sure that they will not do anything that will make the simulator lose its determinism.
Yeah.
So part of the reason why you return these not ready yets and all that, is it because you are making something that can integrate with futures really easily or polling really easily? Is that kind of the idea? Is that you make it hyper embeddable in async, but not necessarily async itself?
Because look, if you have something that can block, the way asynchronous runtime has to deal with that is I had to spawn a thread.
Yeah, a blocking thread specifically.
Yeah, and then it runs your thing, right? So when you do something that is natively asynchronous, the runtime, the futures runtime, can just call you, and then if you're not ready, it calls you again, right? So it's faster, it's better in many ways, and places like the browser may have a lot of problems, like calling threads and spawning threads and doing things like that. So something that is natively asynchronous is better to run in those challenging environments. If you're running this on your Mac, or those things don't matter that much. It may matter for performance reasons, but they don't matter that much. But when you're running things into complex environments, then they do matter.
All right, we're going to move into the Q&A portion of the Top Shelf. We source the questions from the Top Shelf channel in my Discord. And so if you're a part of that, you get to ask questions, and we answer them here on the podcast.
So our first question today comes from Code Girl. What role do you, Glauber, see LLMs playing in the world of databases, if any?
What does it mean about the world of databases? Is it writing database code or?
I think maybe more like you can go wherever you want with it.
Yeah.
Yeah.
Because look, a large part, I know for a fact that a large part of the Limbo code is written by Claude. It's written by Claude through Pekka, because Pekka uses Claude a lot, right?
Yeah.
But still, at the end of the day, look, I'm a fan of LLMs. And I'm a fan of LLMs in particular in code generation. What I'm not a fan of is the idea that some people have that you can get that code and pull it into your project, right? And the way it works better is I have this very complicated thing that I need to do, right? So I'm going to ask the LLM to write it to me as if somebody else was writing, for example, for the Linux kernel. And now I'm playing the role of the maintainer, and I'm scrutinizing, right? And it's great because you can write tons of code at once that it would take you mechanically a lot of time to do. And the other day I was thinking about that. I came up with an analogy that I liked. When I was in university, which happened 25 years ago, so maybe things have changed from now to today. Professors were introducing this amazing technology, PowerPoint. So instead of writing things on the chalkboard, they would come with a PowerPoint presentation, and they would tell you, you don't need to worry about copying. And they thought that they were doing you a great service because they're saving you the trouble of copying the lesson. What I soon realized is that by not copying, I was actually not absorbing it that well. Because in the act of copying and engaging and doing that thing, it's manual work, but it's work that has value, right? It's not work without value, and I think LLMs are very similar. If you ask the LLM to generate code for you, and then you just go and say, look, put the code there, and you don't even know what it's doing. That's the bad way of doing it. But if you're asking LLM, help me with this task, then it's a great way to do it. And the reason this is important is that there are a lot of things in the database world that are very boring, and I guess in many worlds, but they're very boring to do. They're very laborious, and you end up not doing it. right? Or maybe supporting a driver for a obscure language like OCaml and something like that. Like maybe there are 3-4 users in the world, and you end up not doing it because it doesn't matter that much. I mean, it's just a couple of weirdos here and there, like in Jane Street and whatnot.
That's actually just TJ emailing you from multiple accounts.
Exactly.
They let me have an email from them to trick people into believing Jane Street.
Really?
Yeah.
So the 4 that I counted is really just you.
Yeah, it's me from my 4 emails. Yeah,
It's one of those, I forget the name. It's the glasses and the mustache. He's like, oh, yes, OCaml.
So at the end of the day, I think so long as you are the one like still in control of like what goes through, which is again a very similar work of what a maintainer in the Linux kernel used to do. Like there's imagine that. What do you trust more, a LLM or a random dude from the internet? And honestly, the LLM in a lot of ways is better. Like the LLM is much better than I was when I sent my first batch to the Linux kernel that had 3 bugs and 2 lines of code. And the maintainer has to play this role of like reading this and saying okay, not okay. So as long, but you know, those contributions from random people, they give you this dynamism of like, oh, they're doing things that are super boring to do and I would otherwise not do. So in a sense, it's just you have a bunch of interns and it does allow you to do things you would not otherwise do because you wouldn't have the time, you wouldn't have the energy, it wouldn't be a priority. So I think it will help getting smoother, better experiences at the end. But you have to have people that know how to use it, meaning like they are still the ones signing on the code, right?
Yeah. And you also kind of have to have a bit of that visionary mechanic, right? The guy who did that really cool way to be able to fix crashes with Linux and being able to read out what happened in the kernel and the core dumps. Like, you're just not going to get that from an LLM. You have to have somebody that's going to have to first come up with a lot of the ideas and kind of footwork a general conception that you can even describe that problem in a way that an LLM can even remotely come up with a solution that would work. And so there's like a lot of interesting.
But the LLM helps in there as well. The LLM helps in there as well because I mean, I happen to know Eric fairly well. I don't talk to him in a long time, but he had to read a lot of x86 processor specs, right? And so I think the way the LLM helps a lot is that you have this idea: could I do this? And then instead of spending like hours and days and maybe weeks like sifting through like obscure documents, hey, would that work? And then he tells you something, right? And so yeah, you're still in the driver's seat. At the end of the day, you have to be in the driver's seat. But it can help you a lot in the ideation part as well. I'm thinking about implementing this way, or maybe this other way. Would that work or not? And then it's very good because databases and operating systems are systems where you deal with obscure stuff all the time, and the LLMs can be very good at unearthing those obscure stuff and helping you dialogue with them. So it's another way of. But yeah, you have to. The conception has to start on your head, and then you use it as a sounding board, right?
Yeah, I don't know if you've tried the like research mode in any of the LLMs lately, but it's pretty interesting, like seeing it go and just basically like troll through 50 different articles and like get summaries of them and then post links to those articles and to those papers and stuff, which like is much better than when you just ask it and it makes up articles and then supports itself from them. Like, but you know, like that process, like let's say you're like, oh, I spent all my time working on Linux kernel, I just like get thousands of relevant articles, put them in a spot, and I like have it comb through.
Let's go through a real example. Prime is saying here, like, oh, I love the idea of deterministic simulation testing. I don't necessarily quite know how to make it happen in practice. This is exactly, I think, the kind of thing that LLMs can help you a lot with. I want to do it this way. I don't kind of know where to start. Like, you're not even writing code. You're in the ideation phase. But you're playing this game where you know where you want to go, but you know there are potentially 5-6 different paths to get there. And you want the machine to help you understand the concepts, right? And understand like how could you write this? And so it's great. It helps you do things that you would otherwise not do.
Do you see LLMs doing anything inside of the database? I don't even know how. We're interested.
Yeah. What I certainly think, and it's one of the reasons that why I think SQLite is going to be so important, or SQLite or the alternatives, right, which one of them I'm hoping to provide, are going to be so important coming, in the coming years, is that you're going to have a lot more ephemeral data, right? Just a LLM writing code, and then you want like 10% of that code to run an experiment and etc. And you really just want a database that costs you nothing, and that's small, and then you can transfer here and there. So I think this will put a level of demand on databases that didn't exist before. Like as people are writing this code, I mean, what is the next step? Research is now, but the next step is like you will want the LLM to essentially run tests, do all of that. That going back to the analogy, you wouldn't expect the random person like the 20-year-old Glauber contributing to the Linux kernel to just write code. You expect him to have run the code, to have done basic testing. Now you're going to find your own things that this person didn't find, but there's a level of expectation that you must have done all of those things. And I think over time, you're going to have the same expectation out of LLMs, right?
Mm-hmm. All right, number 2. How did Glauber's experience with ScyllaDB translate to starting Terso and libsql and all of that? Any mistakes in the Scylla project that he learned from? From Mitchy Ritchie.
Wow. So I think one of the things that it definitely helped me to start Terso was that I knew I could. I knew I could because in a lot of ways, and like there's this thing going around that people always talk about like imposter syndrome and etc. I don't know if that's the proper name or not, but I had a lingering sense of like, can I start a company? I mean, that sounds really hard. Mm-hmm. Right, that sounds almost impossible, because when you join something that exists, and again before that I spent the beginning of my career in the Linux kernel, Red Hat, etc. Those are mature things. Mm-hmm. It is very hard to understand how things come to be, and it's very hard to understand like what are the challenges at the early days of something are very very particular. Mm-hmm. So I think being part of a early company that nevertheless created a very good database, very highly regarded technically, but I was there in the early days, demystified this a little bit for me, if that makes sense, in the sense like, yeah, I mean, I think I can do it, and also because Scylla was a small company in the beginning, right? Today is not. Today's a big company, but I had to do all sorts of things. I mean, I had to go help the marketing folks and tell people why Scylla is great, and I made many mistakes in helping them do that and led them in wrong directions. And I had to go help salespeople close deals, and so it gave me a lot of experience about like, hey, how do you bootstrap something from scratch? And in terms of mistakes, I mean, I don't know. I think the best person to ask this question is always the Scylla CEO, because he sees what I see as a mistake, he might not see as a mistake, and vice versa. But I certainly feel that we at Scylla should have spent less time committed to the direction of rewriting Cassandra, and more time in the idea of there is something in this ecosystem that needs a facelift, because what became pretty clear to us and again, part of the reason why I eventually left Scylla is that I just don't think that NoSQL is today as relevant as it was back then, right? Mm-hmm. And it became very clear in the beginning of the process when we published Scylla. So we spent like a year and something writing it, and then you put it out in the world. And I think it became very clear that the biggest problem in data at the time was not Cassandra, was Kafka. And then like this other company came along, Red Panda. I'm great friends with the founder. And they used the same to build Scylla. We built an engine called C-Star to do like high performance I/O in C++. So we built this engine to do high performance I/O in C++, and then we built Scylla on top. What I think it became quite clear is that the biggest market was with Kafka. So I think if people at Scylla at the time had more of like this loosely, like strong beliefs loosely held, it would have been easier to notice, oh, maybe let's abandon this, that we've been doing this for 3 months, and let's go chase Kafka instead, because it sounds like a much bigger market. Like Red Panda today is worth north of $1 billion, maybe potentially too. So this is part of the, and in a very when we noticed this, by the way, we were very committed already to, like, it was very hard to dial back. And being very specific how that helped me, this is why now we have a rewrite of SQLite instead of a fork, because we had the fork, but from this experience from Scylla that both Beck and I had, we had this idea that, look, we need to be ready to understand that maybe we're going in the almost right direction. Scylla was in the almost right direction. But if you had just taken a little bit of a turn and said, oh, Kafka is the problem instead, right? And it's what we ended up doing with first the fork and with the rewrite. Yeah, we're going to do a fork. We're going to build the business on it. But we need to be always questioning, okay, is this the right thing? And we need to be questioning at a moment in which we're not so committed to this direction that is impossible to backtrack. So, maybe the founders of Scylla don't see this as a mistake. I certainly do. And they might have more context that I don't, but that's my opinion. And I try to bring this to Torso, right? Just can we keep this for way longer? Of this, are we in the biggest possible market or not? And right.
Yeah, that's interesting. I think I've got our last question here. We already talked about Limbo, but sort of an interesting question referencing it was, what have you learned about SQLite and databases that you, or like Terso, never thought about before starting the complete rewrite?
What I learned about databases that I didn't realize before starting the rewrite.
or about SQLite in particular too, if there's something interesting there.
Well, at that point it has to be about SQLite specifically, because I wrote with this. This is my third database, right? Just
yeah.
But it's just at Scylla I had this experience. I mean, things about databases that I never thought before. Man, I think one thing certainly is how messy SQL is. I mean, SQL is pretty messy. SQL is pretty messy. I don't fault the people who think that they're going to come up with something better. I think they're all going to fail, but they're going to fail because of the weight of the ecosystem. Right? There's the weight of the SQL ecosystem is huge, but it's kind of terrible. It's kind of terrible. I knew nothing about simulation testing, so there's definitely something there that I think for me was very critical. I don't think I would write a system today that would not use deterministic simulation testing. So there was definitely something in that transition. What else? It's interesting. I think a lot of people don't realize what SQLite is and can be, which is another lesson. Like, for example, a lot of when we talk about synchronous and asynchronous, one thing we hear a lot is it doesn't matter because the SQLite queries are so fast, like they take 300 microseconds anyway. So why bother? Synchronous is fine. And again, this isn't true because a lot of SQLite queries take 2 minutes. Because if you're doing a CRUD query on a database, yes, select age from users where ID equals 2. That takes 20 microseconds or whatever. If you're doing and SQL is really geared towards this. Like if you're doing a very complicated recursive query for your business intelligence of like find me all the users in the last 3 months who churn with this criteria of churn, which is, by the way, queries that we do a lot on Torso to understand like the user journey. Those queries are very, 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 very slow. So SQLite can be very slow for those very complicated queries. And I think this is something a lot of people don't realize, right? Lessons, we keep learning lessons every day, but those 3 are the ones that come from the top of my head.
But to be fair, they're generally slow in every database.
That's my point. Yes. Yeah. So you can't afford to. It's not that SQLite is bad on those queries. There are exceptions, by the way, because if you go look, this is the domain, by the way, where I think NoSQL is awesome. You have this query that takes an hour, 2 minutes, whatever, and this query is high value enough that you can build a database that lays out the data specifically for that query. And the best example is time series databases. Like, so time series, if you try to do time series on any SQL database, they're going to suck. You have then a time series database because it lays down, what you want is an aggregation. So we're going to pre-aggregate everything. We're going to lay down data in which the columns are all close together because you can just scan them. You don't have to be pointer chasing. So those are the domains where I think like specialized databases are awesome, like those queries. But yet you have your data in the SQL database, right? And in many cases, you're fine taking 2 minutes. So you want to do it in there, and you don't want to have that done through a synchronous interface. The better SQLite 3 package, for example, for JavaScript, is a synchronous package, and that's what they argue in their README. It's fine because SQLite is fast, right? And it's not, just because sometimes it's not fast, because no other, like you're doing a super complicated query.
I think that's probably due to the fact that people's view of SQLite is very one-dimensional. Oh, you just put very light user settings in this, or you put very small things. It's a very ephemeral or light database. So therefore, it's always fast, right? But the argument here is, no, actually, we're putting bigger things in here. Therefore, that argument of light or quick no longer exists.
Or a different backend in the case of like Terso. Yeah.
Great point. Because one thing I learned with this experience of SQLite is exactly this: how those things are relative. Because our first demo of Scylla. So Scylla, for those who don't know, is a horizontally scaling database. It essentially can horizontally scale infinitely. You can just add more nodes, and if you add twice as many nodes as you have now, it gets twice as fast. That's the. It's not always true, but that's the selling point, right? The first demo that we did when we launched Scylla is like Netflix at the time had this benchmark where they did like 1 million writes per second with a 52 nodes of Cassandra, and then we had Scylla doing 1 million writes per second with 1 node of Scylla, which was actually a pretty terrible benchmark, because what a lot of people understood from this is that Scylla could not scale horizontally. Because
you should have chosen 2 nodes.
We should have chosen 2, right? Just 2 millions with 2 nodes, but we never expected that. But I spent 8 years working with Scylla, right? And then when we started working with SQLite, people would come and ask me, like, I have this very write-heavy workload. Can I use SQLite for it? And I don't want to mislead anybody. I would just say no. SQLite is not a database that is designed for heavy writes. But then I got into the habit of asking people, how many writes are you doing? And I would hear answers like, we write to the database almost every second. And I said, look, that's fine. You can use SQLite just fine for that, right? So when you move, which by the way, Prime, this is something that I appreciate a lot about you. This is the moment, and I said that in public before. I want to say it again.
Oh, we're gonna have to end the podcast after this.
Yeah, and because I do have to go.
He doesn't appreciate you, TJ. Just so you know, camel man.
Yeah, I already heard him talking about me. Okay.
I do have to go get my daughter, but like you have a very rare skill of like understanding that different things in different places work very, very differently. And what we see a lot in the industry is just like, hey, why would you ever have more than 5 gigabytes in your database? Like, who needs more than that, right? Just and variance. But look, when you move from market to market, when you move from use case to use case, the definitions that people have of what is big, what is large, what is fast, like they change completely. Like you talk to people and say, we want those queries to be very fast. They have to be done in less than 100 milliseconds. And then you go talk to the ad tech folks, like the ones serving ads in your browser. Like if this query returns in more than a millisecond, they're calling you and say, the database is freaking slow. So and then again, and you have 1 million writes per second with Scylla, and in the web domain, like I have people telling me, we write to the database almost every second. Man, this is heavy writes. You must be able to handle my amazing writes. Which again, I'm not discounting. It's just to show, and this asking me about what I learned, like how like you move a little bit out to a different domain, everything changes. Like everything changes. Whatever you learned before doesn't apply, right?
Yeah. For those that don't know, if you had 100,000 writes in a day, which is larger than a lot of companies do not meet the threshold of 100,000 writes per day. That is 69 writes per minute. And so it's nice, right? So it's actually very not as high as people realize. That's on average. Obviously, it's going to be much more bursty and all that kind of stuff. But people often over-index into what they think is happening when you're like, okay, you're not really on the millisecond scale or let alone the microsecond scale. Like, you got to realize that your scale is much smaller. So almost all questions you're asking are irrelevant until you get to the billion users.
It is very funny how, if you're going to measure per minute versus per year, it'll sound like a lot or a little.
Yeah, a
writes.
billion writes per year.
Oh
It's not a
my
lot.
goodness, they're huge. Well, that's how you pump the VC money. But anyways, Glauber, thanks a bunch
My pleasure,
for coming.
folks.
We had a good time with you, and
Likewise.
honor getting to chat with you. And we look forward to next time we can have you on.
I wish I could
And
say
I
the
look
same
forward to the
about
next
you, man. Just kidding.
Brazilian mojito with
There you go.
Let's go, man.
Awesome.
I'll see
All
you
right,
in Turkey,
thanks.
Brian. Let's go.
Yeah, we'll see you guys
See you,
next
folks.
episode.